Gurmin, you have learned a lot about polynomials, right?
Yes, that's true. That's true.
Now it's the quiz time.
Okay.
So I'll sketch a polynomial graph
Okay.
and you have to write its equation.
Okay.
Can you do it?
I think so.
Okay.
Yeah.
Let's try it.
Okay.
So I'll just draw a graph here and you provide me this equation.
Perfect.
So let's say, let me make types of zeros. So this is one type of zero.
Yeah.
And the function is kind of.
Okay.
Now here it moves to quadrant 2, bounces back, and then.
So what I can already tell is that this is an even degree function, but the leading coefficient negative.
Okay,
That's something I can tell.
that's perfect. I want degree 10 equation. And
Okay.
let's take this point as minus 5. This is of course 0. And let's take this as 4.
Okay.
Yeah.
All right. So
Come on this side.
we can start off
Yeah.
with f of x. Let the function be f of x.
Yeah.
So let's say this is f of x. Now leading coefficient, let's say, is 1, but
Okay.
negative,
Okay.
because remember it's facing down and it's even, right? Now let's start off with our zeros, right?
Okay.
So this is, if it's negative 5, if you put in a fracted form, it would be plus 5,
Okay.
right? And then x,
Yeah.
right? And then here you'll have x minus 4.
Yes.
Now, as far as the degree is concerned, 10. If there's a linear, you have to put a 1.
Yeah, that's 1.
That's a 1.
Yeah.
There's no choice about that. And now you have to look at, in order to decide what the degree of this is going to be, you have to look at the way it's shaped at the turning point. So this is more or less cubic,
Yeah.
right? So let's say let the degree be 5.
Okay.
What about 5?
So it could be odd. 3, 5, 7.
7, right? So let's say if it's 5.
Okay.
Now we need to get to 10,
Yes.
right? Now 5 take away 1 is 4, right? So this could be 4.
Yes. So 5 plus 4 is 9 plus 1 is 10.
And
It's the turning point there.
right, and why
Perfect.
now why did I choose these numbers? Is because this is 5, because this is odd, right? X to the power of 4 because this is even. Remember, it turns. And 4 to the power of 1 because this is a linear.
Perfect.
So
That's good example.
There you
now,
have it.
give me another equation for degree 10 on the same graph.
okay.
Try to give me another equation. Yeah. We could write many equations, right?
Yeah.
This is one, for example. So if I change this to some other number, then
You could
give me another equation.
you could try 3,
Okay.
right? Because 3 is also
Yeah.
3 is also an odd degree. Then let's say, but this stays 1, right?
Yes,
because
this stays 1.
because you have to
So
look at
3
the
plus
shape,
1 is 4.
right?
Out of 10, we are left with how?
6.
6.
Right. So here's you have it 6.
So that's how you could do many different combinations,
Right.
correct? So in this, we had an x-intercept at origin.
Yeah.
Let me give you another example. We have some other y. So,
Okay, why not?
Okay, so we'll do that.
Okay.
So Gurmin, let me give you odd degree function this time.
Okay, why not?
Let's see if you can get the equation.
Equation
for
from
us.
the graph. Okay.
So odd degree really means that it ends up here
yeah.
and opposite, right?
Yeah.
So kind of starting.
Okay.
So let's say it goes, turns, and then it goes like this. Think this is a cubic. Right?
Yeah.
Let's take this point as 1. Let's take this point as minus 2.
Okay.
And the y-intercept, let this be at, let's say, a minus 100.
Okay.
Okay?
All right.
Now give me equation of this. If the degree, let us say, the degree is
7.
7.
Okay.
Okay. Now give me equation of this function.
Okay. All right. So let this be f of x. I'll just write on the side.
Okay.
And now we don't know the a value, and how I know that is because we have a point that's given to us for a reason. But that would be taken care of later. So we can write a, which is unknown to us. But we do know our x-intercept, so let's start off with that. X plus 2, x minus 1.
Yes.
There's nothing linear here, so you don't have to worry about it. Now, this is even, this is odd.
Yes.
And even and odd, the degrees have to add up to 7. So why don't we make this 4?
Okay.
So we can make this 4 because it's turning point. So this has to be an even degree. 7 take away 4 is 3. So this can be 3.
That makes it perfectly
Right?
degree 7. Yes.
Because this is odd, so you have to have an odd degree, right? Now, we can utilize this point to find what the value of A is. Now, just knowing that the leading coefficient is positive because the right side is up is not enough. We have to know the value.
Correct.
So why don't we do negative 100, because that's our y-intercept, remember?
Yes.
0 and a negative 100.
Good.
Negative 100 equals 0 plus 2 to the power of 4. 0 minus 1 to the power of 3,
Correct.
right?
8 times.
Times 8. Sorry, thank you. So now 2 to the power of 4 we know is 16,
Yes.
right? 16. Negative 1 to the power of 3 is negative 1, right? So instead of
Negative.
writing negative 1, we'll just make it negative 16,
Okay. Yeah, that's right.
right?
Perfect.
Negative 16.
Yes.
Now, A has to be 100 over 16.
So both negative
Both are
cancels
negatives.
out. So A is 100 over 16.
Right.
So that's your answer.
Right. So if you want to write this as a final equation, what you can do is, let's write it as a final
Right.
equation. So let f of x equals to 100 over 16, leading coefficient positive, opposite ends, odd degree, x plus 2 to the power of 4 times x minus 1 to the power of 3. Everything satisfied. The
Perfect.
degree 7,
Yeah.
your leading coefficient is positive, right side up, and the zeros match, and the degrees match the trending points.
Yes. You can always simplify this
Of
expression.
course, yeah,
No problem.
no problem.
That's perfect, Gurmeet.
Thank
Great
you.
job done.
Thank you.
So that means you've really understood.
Yes, I do.
Great.
Thank you.
That's good. That's perfect.